Hi guys, welcome back. Today we're talking about algebraic expressions. Whenever we are given an expression with known variables, we find the value of the expression by substituting in the values for each variable and evaluating the expression. A variable is an unknown value which represents a number in an algebraic expression. An example of a variable would be the letter x, which would represent a different value depending on the expression. So for the first example, we are asked to evaluate the expression 3 multiplied by 2x plus 4y when x is equal to 5 and y is equal to minus 2. So in this case, our known variables are x and y, since the values of both x and y are given in the example. So we must substitute in the values for each variable and evaluate the expression. So substituting x and y into the expression, we are left with 3 multiplied by, and then in brackets, 2 multiplied by 5 plus 4 multiplied by minus 2. Simplifying inside the brackets, we are left with 3 multiplied by 10 minus 8, which simplifies to 3 multiplied by 2, and 3 multiplied by 2 is equal to 6. The second example states that we must evaluate the expression x squared plus 2xy plus y when our known variables x and y are equal to minus 2 and 4 respectively. So firstly, we have to substitute in our known variables. Substituting in for x and y, we are left with minus 2 squared plus 2 multiplied by minus 2 multiplied by 4 plus 4. This simplifies to 4 minus 16 plus 4, which is equal to minus 8. For our third example, we are asked to find the value of x when y is equal to 2 and z is equal to minus 1. So here, our known variables are y and z. The question also states that x is equal to the square root of 2y minus 4z. So substituting in our known variables y and z, we get x is equal to the square root of 2 multiplied by 2 minus 4 multiplied by minus 1. This simplifies to x is equal to the square root of 4 plus 4, which again simplifies to x is equal to the square root of 8. In the final example, we are asked to find the value of the expression 2 divided by 3x plus 6 minus 3 divided by 2y minus 2 when x is equal to 1/2 and y is equal to 3. So the first thing we do is we take our known variables and we sub them in. Once our known variables are substituted into the expression, we can then simplify the expression. As a first step, we can multiply 3 by 1/2 in the denominator of the first fraction, and 2 by 3 in the denominator of the second fraction. In the denominator of the first fraction, we can now add 3 divided by 2 plus 6. Now if you can remember from a previous video on rational numbers, in order to add or subtract two fractions, they must have a common denominator. So if we multiply 6 by the denominator of the first fraction divided by itself, or 2 divided by 2, we are left with 6 is equal to 12 divided by 2. This does not change the value of 6, since 12 divided by 2 is still equal to 6. So now that we have 6 is equal to 12 divided by 2, we can add 3 over 2 and 12 over 2, since they have the same common denominator. 3 plus 12 is 15, so 3 over 2 plus 12 over 2 is equal to 15 over 2. We can simplify the denominator of the second fraction by subtracting. So 6 minus 2 is equal to 4. So now for the first fraction, we have 2 divided by 15 over 2. If you recall from my video on rational numbers, dividing two fractions is the same as turning the second fraction upside down and multiplying them. We can think of 2 as 2 divided by 1, since 2 divided by 1 is equal to 2. So 2 over 1 divided by 15 over 2 is equal to 2 over 1 multiplied by 2 over 15. We also talked about multiplying two fractions. So when multiplying two different fractions together, we multiply the numerator by the numerator and the denominator by the denominator. So here we multiply 2 by 2, which gives us 4, and we multiply 1 by 15, which gives us 15. so we're left with the fraction 4 over 15. Now in order to subtract 4 over 15 by 3 over 4, the two fractions must have the same common denominator. So we can multiply each fraction by the denominator of the other fraction divided by itself in order to scale up the denominators so that they are equal to each other. This has no effect on the fraction, since multiplying a number by a different number divided by itself is essentially multiplying the number by 1, because any number divided by itself is equal to 1. So we get 16 divided by 60 minus 45 divided by 60. 16 minus 45 is equal to minus 29. So 16 over 60 minus 45 over 60 is equal to minus 29 over 60, which is our answer. We must be able to use various properties of multiplication in order to simplify algebraic expressions. So as a way to begin, I'm going to talk about the associative property. The associative property of multiplication states that if we multiply two numbers, a and b, and multiply the result by another number, c, that this is the same as multiplying the number a by the result of multiplying the two numbers b and c. So changing the order by which we multiply different numbers in a sum does not change the answer that we end up with. The distributive property is a very important property since it shows us how to multiply a number or a variable by some brackets containing multiple terms. Here, we want to multiply a by b plus c. This property states that this is equal to a multiplied by b plus a multiplied by c. So what the distributive property states is that if we multiply a number a by a bracket containing multiple terms, such as b, c, d, etc., we must multiply a by each term inside the brackets. Depending on the signs of each term within the brackets, we will end up with different signs in our answer. So for example, if we were multiplying a by b minus c, we would end up with a multiplied by b minus a multiplied by c. Now, instead of having just a being multiplied by b plus c, we are now multiplying a plus b by c plus d. So in this case, we must multiply a by c plus d, and then multiply b by c plus d. Since all of the signs are positive, we then must add a multiplied by c plus d with b multiplied by c plus d. The way in which we use the distributive property is drawn in by the arrows as shown. You can clearly see that a multiplied by c plus d plus b multiplied by c plus d is equal to ac plus ad plus bc plus bd. So by following the arrows, we make sure that we do not miss any terms when multiplying out our brackets. So for our first example, we are asked to simplify 2 multiplied by 3x plus 6 minus 3 multiplied by x minus 10. Straight away, we can see that we must use the distributive property, since we are multiplying numbers by brackets containing multiple terms. So to begin, we multiply 2 by 3x and 2 by 6. All of these numbers have positive signs, so we must add them both together. Now we multiply minus 3 by x and minus 3 by minus 10. This simplifies to 6x plus 12 minus 3x plus 30. Now at this point in the video, if you're getting confused by the different signs, it would be worthwhile to go back to my video on integers, where I talk about how to multiply numbers which have the same signs and which have opposite signs. We can rearrange our sum to have x's on one side and numbers on the other. So we end up with 6x minus 3x plus 12 plus 30. Simplifying by adding and subtracting, this leaves us with 3x plus 42. So for our next example, we are asked to simplify 2x plus 2 multiplied by xy squared plus 3. Again, we must use the distributive property. So here we multiply 2x by xy squared plus 3 and add this to 2 multiplied by xy squared plus 3. Again, we must use the distributive property since we are multiplying numbers by brackets containing multiple terms. So now we multiply 2x by xy squared and add this to 2x multiplied by 3. So then for the second term of the expression, we multiply 2 by xy squared and add this to 2 multiplied by 3. We can now simplify this as 2x squared y squared plus 6x plus 2xy squared plus 6. We can then rearrange our expression to be left with 2x squared y squared plus 2xy squared plus 6x plus 6. For the final example, we are asked to simplify x plus 2y squared and evaluate it when x is equal to 3 and y is equal to minus 2. So anything squared is the same as multiplying it by itself. So x plus 2y squared is equal to x plus 2y multiplied by x plus 2y. We can now simplify this using our distributive property. So we multiply x by x and x by 2y, 2y by x, and 2y by 2y. These are all added together since all of the numbers inside the two brackets are positive. X by x is x squared, x by 2y is 2xy, 2y by x is 2xy, and 2y by 2y is 4y squared. We can add 2xy and 2xy and we get 4xy. And then rearranging our expression, we are left with x squared plus 4y squared plus 4xy. Now we were asked to evaluate the expression when x is equal to 3 and y is equal to minus 2. So substituting our known variables into our expression, we are left with 3 squared plus 4 multiplied by minus 2 squared plus 4 multiplied by 3 multiplied by minus 2. This simplifies to 9 plus 4 multiplied by 4 plus 4 multiplied by minus 6, which again simplifies to 9 plus 16 minus 24. 9 plus 16 is 25, and 25 minus 24 is equal to 1. Before moving on, we're going to take a look at a couple of the rules of indices. So any expression, a to the power of x, has a base, a, and it has an index, x. The index is more commonly known as an exponent or a power. Today I'm going to cover 3 very important rules of indices when dealing with algebraic expressions and factorizing. So the first rule states that the expression a to the power of x multiplied by the expression a to the power of y is equal to the expression a to the power of x plus y. So we can see that when we multiply two numbers with the same base, we must add their powers. The second rule of indices states that the expression a to the power of x divided by the expression a to the power of y is equal to the expression a to the power of x minus y. So we can say that when we divide two numbers with the same base, we must subtract their powers. The third rule states that the expression a to the power of minus x is equal to 1 divided by a to the power of x. So when we encounter an expression with a negative power, we can equivalently write it as 1 divided by the same expression, just with a positive power. You should dedicate a page in your notes copy to the rules of indices, and begin by writing these 3 down. At this stage, it is very important to understand these rules, as I will be using them from now on. So in my previous video, I covered 3 very important rules of indices that we're going to need from now on. These rules tell us how to multiply and divide the same variables by each other. So for the first example, we're asked to simplify 3x squared divided by y squared multiplied by 5xy divided by 3. So if you can't remember how to multiply two fractions, you should take a look at my video on rational numbers. In that video, I explained with examples that when we're multiplying two fractions, we must multiply the numerator of one fraction by the numerator of the other, and the denominator of one fraction by the denominator of the other. This can also be known as multiplying top by top and bottom by bottom. So in this case, we must multiply 3x squared by 5xy and y squared by 3. We end up with 15x cubed y divided by 3y squared. So on the numerator, you can see that x squared multiplied by x is the same as saying x squared multiplied by x to the power of 1. In our first rule of indices, we have a to the power of x multiplied by a to the power of y is equal to a to the power of x plus y. So in this case, x squared multiplied by x is equal to x to the power of 2 plus 1, which is equal to x to the power of 3. We can also simplify the fraction by dividing y by y squared. Y divided by y squared is the same as saying y to the power of 1 divided by y to the power of 2. According to the second rule of indices, a to the power of x divided by a to the power of y is equal to a to the power of x minus y. So y to the power of 1 divided by y to the power of 2 is equal to y to the power of 1 minus 2. 1 minus 2 is equal to minus 1. So y to the power of 1 minus 2 is equal to y to the power of minus 1. Taking a look at the third rule of indices, a to the power of minus x is equal to 1 divided by a to the power of x. Therefore, y to the power of minus 1 is equal to 1 divided by y, or 1 divided by y to the power of 1. We must remember that any number to the power of 1 is just equal to the number itself. So then our answer for the simplified fraction is 5x cubed divided by y. The second example asks us to simplify 2y squared divided by x divided by y divided by 4x squared. Again, if you forget how to divide two fractions, it may be worthwhile taking a look at my video on rational numbers, where I explained when dividing two fractions, you must turn the second fraction upside down and multiply. So by applying this principle, we end up with 2y squared divided by x multiplied by 4x squared divided by y. Now we just have to repeat what we did in the very first example. If you remember, we must multiply the top by the top and the bottom by the bottom. This leaves us with 8x squared y squared divided by xy. X squared divided by x is the same as saying x squared divided by x to the power of 1, which is equal to x to the power of 2 minus 1, which is equal to x to the power of 1. And we said that any number to the power of 1 is equal to the original number. So x to the power of 1 is equal to x. The same principle applies for y squared divided by y. So therefore, we are left with 8xy for our answer. If you remember back to my video on rational numbers, I explained that when adding or subtracting two fractions, they must share a common denominator. That is, a denominator which is common to both fractions. Taking a look at our example here, we are asked to simplify 2x minus 6 divided by 5 plus x plus 7 divided by 3. So as we know, in order to add these two fractions, they must share a common denominator. In order to do this, we take the denominator of one fraction and multiply it by the denominator of the other fraction. However, we have to multiply it by the numerator of the fraction as well, in order to not change the value of the fraction. This is because any number divided by itself is equal to 1, and multiplying any number by 1 gives you back the original number. Now we can say that the denominators 3 multiplied by 5 and 5 multiplied by 3 are both equal to 15. Since both fractions have the same denominator of 15, we can now add them. We can further simplify this by multiplying out the brackets in the numerator of this new fraction. After multiplying out the brackets and rearranging in order to have x's on one side and numbers on the other, we are left with 6x plus 5x plus 35 minus 18 in the numerator of the fraction. 6x plus 5x is 11x and 35 minus 18 is 17. So we end up with 11x plus 17 divided by 15 as our answer. Our second example covers algebraic subtraction. We could also make note that the variables are on the denominator and not the numerator of the fraction this time. This makes no difference, as the steps used in the previous example will be used in this example in the same way. So multiplying and dividing each fraction by the other fraction's denominator, we end up with a common denominator of x minus 5 multiplied by 2x plus 1. The two fractions can now be subtracted from one another, since they both share a common denominator of 2x plus 1 multiplied by x minus 5. Further simplifying the numerator by multiplying out the brackets, the answer of this question is 2x minus 23 divided by 2x plus 1 multiplied by x minus 5. Thanks for watching this video, and please subscribe to my channel as I upload maths videos every single week. If you benefit from these videos, you should save my playlist, which should be in the description of this video. I have multiple playlists on my channel, depending on what topic you're trying to learn. And if you do have any video suggestions, feel free to leave them in the comment section below.